Hi, this is Babak. In this video I am going to solve the following problem for you. In this problem we're supposed to show that this number, which is actually a huge number, is equal to 16 to the power of 2 to the power of 99. That would be a good idea if you can pause the video at this moment and try to solve the problem yourself first. Okay. My strategy in solving this problem is to start manipulating the left-hand side and reach to the right-hand side. So I would write the left-hand side is equal to 1 plus, so let me change my color. I would write 2 to the power of 2 to the power of 0 minus 1. I will explain this in shortly. So and then I would write 2 to the power of 2 to the power of 0 plus 1. Then I would write 2 to the power of 2 to the power of 1 plus 1. And then 2 to the power of 2 to the power of 2 plus 1. And this, of course, will continue until I will reach to the last pair of brackets. So 2 to the power of 2 to the power of 100 plus 1. And of course, it becomes clear that when I reach to this last step, the previous step would be 2 to the power of 2 to the power of 99 plus 1. I'm just writing this for the guidance. But you might say that, okay, what is this one? Of course, I hope that you agree with me. There is no difference between what I have written here and the left-hand side of this expression. Why? Because 2 to the power of 0 is 1, and then I will have 2 to the power of 1 minus 1, which is 2 minus 1, which is 1. So it seems that I have multiplied this expression by 1, and of course you agree with me that there is no difference between this expression and this expression that I have written here, because this expression is exactly equal to 1. But you might ask, what is the benefit of that? Okay, let me change my color here to explain something here for you. So I want to show something. So I would say that let k be a non-negative integer. Yes? And then we want to show this. I want to show that if I have this expression 2 to the power of 2 to the power of k minus 1 multiplied by 2 to the power of 2 to the power of k plus 1, this becomes equal to 2 to the power of 2 to the power of k plus 1 minus 1. Okay, so this is something that I want to show. I want to show that this expression, this equality holds for any non-negative integer k. Okay, and then I want to use the conjugate pattern, conjugate identity. So you know that the conjugate identity, if I have two numbers a and b, once subtracted, once added, and then I want to multiply them, I know this becomes the first one squared minus the second one squared. So I hope that you immediately realize that in what I have written here, this is playing the role of A, and this one is playing the role of B. So I will have the conjugate pattern. So here I would start again from the left hand side. This becomes, according to conjugate identity, I can write the first one, 2 to the power of 2 to the power of k to the power of 2 minus 1 to the power of 2. But we also know that if I have some number a to the m and I want to exponentiate it to another power n, then what I need to do, I need to multiply the exponents, yes? So this is also, we know from elementary mathematics. So here, this one is playing the role of this a. 2 to the power of k is playing the role of m, and this 2 is playing the role of n. So what happens is this becomes 2 to the power of 2 multiplied by 2 to the power of k, and then minus 1 to power 2 is nothing except 1 itself. Yes? So what I have done, this is m, this is n. So m times n becomes 2 to the power of k multiplied by 2. But I have two exponents with the same basis, and I have to write the same base and I add the exponents. So this is why instead of this expression I can simply write 2 to the power of k plus 1 minus 1, and that is exactly equal to the right hand side. Yes, so if I have this combination on the left for any non-negative integer, instead of writing this as a product, I can summarize it in this form, but the price that I have to pay is to change k to k plus 1. So that is the rule that we learned here. Okay, so now let me copy and paste all these expressions here. So let me just copy this and put this here, and yes, so let us see what is going on now. Okay, so here now, if I consider only this part, you agree with me that this expression that you see here is of this form, but k is 0 here. So according to this rule, I can combine them into one expression, but the price that I have to pay is to add 1 unit to the value of k. The value of k is 0, so it becomes k plus 1. So this becomes 2 to the power of, so the k value is 0, the value becomes 1 plus minus 1. Yes? But now this one with the next one makes the same pattern for me, in which k this time is 1. So I can multiply this by the next one. The only thing that I have to do, I would write 2 to the power of 2, but instead of k, which is 1 in this case, I have to add 1 to it. It becomes 2 minus 1. And again, the story will continue. This one with that one, for the same reason, becomes 2 to the power of 2 to the power of 3 minus 1. Yes? So I am using this pattern over and over again. So if I continue this, this will continue until I will have the previous one, which is 2 to the power of 2 to the power of 99 minus 1. This will multiply itself here, and then this will produce 2 to the power of 2 to the power of 100 minus 1. But then again, this one with the last one will give me 2 to the power of 101 minus 1. So this means that the left hand side becomes equal to, I had 1 here, so I will write this down, plus, then I learned that all this expression becomes 2 to the power of 2 to the power of 101 minus 1. But then what happens? This minus 1 and that one are cancelled, so this becomes 2 to the power of 2 to the power of 101. Still, I haven't reached to the right hand side, because the right hand side is supposed to be this number, but then it becomes clear. So what can I do? I can write 2, instead of 2 to the power of 100, I can write 2 to the power of 2 multiplied by 2 to the power of 99, yes? So if someone asks you what is this expression, I would say that this is exactly equal to this, and you see that this 2 is just the same 2 here. What is the benefit of that? This can be written as 4, so this becomes 2 to the power of 4 multiplied by 2 to the power of 99. But then I can write it as 2 to the power of 4 to the power of 2 to the power of 99, exactly according to the same rule here, but from this direction to this direction. But then 2 to the power of 4, everyone knows that this is just 16. And then I have to copy and paste this exponent, which is 2 to the power of 99. And then it becomes exactly equal to the right hand side. Okay, I hope that this video is useful. Until the next video, be safe and goodbye.